Hey everyone, Mr. Newman here, and we're going to look at the 4.5 standard again, and I'm actually going to give you guys some pointers or tips for when you're graphing sine and cosine. So first of all, let me give you the problem I'm going to do. I'm going to try to sketch this graph right here, or this equation right here, and I'm going to show you the order in which I'm going to do that. So first thing I want to do is you see that the center line is 1. That's because we add 1 to the output of the function. So I'm going to draw my center line right there. I mean, the amplitude needs to come from there, and yeah, that's just the center of the function. Notice the next thing I look at is this plus pi here. That's because that is the phase shift, and so I know that, remember, the graph is going to move the opposite direction of what you think, and if you remember the formula, it's actually minus d. So plus pi means it moves left pi, so I know that that negative pi is where I'm going to start. Before I draw a point, though, I need to look and see, is this cosine or sine? And because it's cosine, I know we're not going to start on the center line. We're going to start at the top of the function, above the center line. And how high up is determined by that 3 right there, which is the amplitude. So the first point I plot is at negative pi, comma, 4. In other words, negative pi is the phase shift, and moved up 3 from the center line, because it's cosine, is that point. Now that I know that, I should look for the period. Well, fortunately, we're not multiplying anything by x, so the period is just 2 pi here. And that means that I can move from that point. I'll move over 2 pi to the right and plot that point as well all the way over there. Next, because this is cosine, I know that halfway between those points will be the very minimum of the graph, the very bottom of the graph. So halfway between these is actually x equals 0, or in other words, the y-axis. And I'm going to look at 3 below that center line because it is the amplitude. So I'm going to draw a point right down there, 3 below the center line, exactly halfway between those points. Then, halfway between the x values now is where the graph actually meets the center line. So I want to fill in those points at negative pi over 2 and pi over 2. Notice how there's a nice symmetry here, and I'm thinking about what this graph looks like. I don't want to just draw a V here, though it looks kind of like that. I want to make sure I curve it and that it's steepest at those points on the center line. So I'm going to get something that looks like this. All right. Notice it's not a perfect sketch, and it's kind of ugly, but it hits the points, and it is close enough that that is perfectly fine for my standards. So let's fill in a few more points here. Notice I can just keep this pattern going, so I'm going to draw another point to the right. It's going to hit the center line, pi over 2 more to the right, and then it's going to be another minimum pi over 2 past that. I can connect on the left side. There'll be another center line pi over 2 to the left, and then pi over 2 past that will be another minimum. Notice I connected those, and notice it curving, so it slopes down to its least steep at the minimums and maximums. And that's one important thing to notice, is that I just graphed 2 periods, and I generally ask for you guys to do that. At least have 2 whole periods on the graph. Some of you guys might be thinking, but wait, I thought peak to peak was a period. I only see 1 period. Well, remember, peak to peak is a period, but so is the minimum or the valley to the valley, right? Or minimum to minimum. So the whole graph is actually 2 periods there where it repeats. Let me just recap how the different steps we did there. First of all, the center line, we sketched the center line. Then we looked at the phase shift and found the starting point. That was negative pi. Then we determined whether it was sine or cosine, so that decides whether we start middle or high. And then I found the amplitude, and that actually let me plot the point. So I put all those green ones, 2, 3, except 2, 3, and 4 are kind of together because that's to get your first point. And then we find the period, and that lets me plot up all the way to the right, the period length, so that lets me plot the second point. And lastly, we plot the points that are in between, and we connect those with the curve. So those are your steps that you generally want to follow. Let's do one more practice problem with a few other tricky parts to it, okay? This time I'm going to do this function. Notice there's no adding on the outside, so that means the center line is going to be at y equals 0. But the tricky part about this, so there's a few, the big one for me is that that 6x minus pi is not in the format that we originally discovered each of the 4 variables in. If you remember, the format had sine of, and the input looked like this, b times parentheses x minus d. To be honest, this is the easiest format to graph functions in. So I would rewrite, if I were you, I would rewrite the function in that format. Let me show you what I mean. I'm going to rewrite the whole function, but instead of 6x minus pi, I'm going to put 6 times parentheses x minus something. In other words, I'm factoring out a 6 from inside that parentheses. And the question is, what do I put there? Well, what times 6 equals pi? That'd be pi over 6. That means that my phase shift is pi over 6. Notice that because this is sine, I'm going to start in the middle, so I don't even need to consider the amplitude yet. I know that my first point will be right there on the center line at pi over 6. And notice it was minus pi over 6, so we're going to the right pi over 6. All right, the next point is going to be the period over, and then you need to remember this formula here. Period is 2 pi over b, because I now know that b is 6, so the period is 2 pi over 6, also known as pi over 3. When I go pi over 3 to the right from pi over 6, you actually land right on pi over 2. The reason for that is because pi over 6 plus pi over 3 is pi over 2. You can check that by adding those fractions. So there, right there, is my whole period of my function. I need to squeeze all the points in between that. So first of all, halfway between that, I'm not going to write down the exact value, but you could calculate that. If I give you a scale like this and I don't actually mark the values in there, I would say doing exactly what I'm doing here on the graph is perfectly fine. And then the next one, you notice I plot up there, might be this because it's sine, but I'm going to cross that out because I need to recognize this negative in front of the 3. What that does is that flips the graph vertically. So instead of the amplitude being up 3, the amplitude is actually down 3. So the amplitude is actually still 3. But I need to notice that instead of going up from my starting value, sine is going to be going down from my starting value. If I had cosine, that would mean instead of starting high, I would start low. So let's erase that and let me plot the point 3 below, halfway between those 2 points. And then halfway between the next 2 points, I plot it 3 above. Now I'm going to do that again. I'm going to move over not 2 pi. I'm going to move over pi over 3, and because that's the period. And then I'm going to plot a point halfway between that, and between those first 2 points, I'm going to go low, and the second 2 points, I'm going to go high. And notice I'm always returning to the same 3 away from the center line, because that is the amplitude. Now I'm going to connect these dots, and it's going to be kind of ugly, but you can see where I'm going with this. And honestly, if yours is as ugly as mine, that's perfectly fine. The main thing is that I'm guided by those dots, so that's what is most helpful. And now that I've graphed those dots, I've graphed my 2 periods of my function, so I am done. One thing you could do, especially early on as you're graphing these, is to check each of your graphs with Desmos, just to make sure that you graphed it correctly. Obviously, you won't be allowed to use Desmos on the quiz, but while you have it, it's a good idea to practice until you feel pretty confident that you're getting the answer correct. Thank you for watching.